Blue snowball. Blue snowball. All right, we're back. It is COMP1004. That's Rapid Application Development here at Georgian. And we are week 4, part 1 of our broadcast. Week 4 kind of flew by. 4 weeks together. We've been a month together now today. And we just finished discussing offline about the assignment number 1. And again, all I can do is urge people who have not handed it in yet. It was due last night at midnight. Please hand it in today. That means you'll lose almost, between 5 and 6 marks, 27. So 5.4 marks equivalent, exactly right, out of your 27, which means you still have a good chance of getting 21.6 if you did perfectly on your assignment tonight, which is still a pretty good mark. It's not great, but it's not a fail. All right. Let's talk about the stuff we're going to be discussing today. So one of the things I want to talk about, it's posted, is assignment 2, right? So assignment 1's gone. It's behind me now. Assignment 2 is what we're going to be talking about. And I want to talk about how it's different than assignment 1. Because some people, in the past, they'd be like, assignment 2 looks a lot like assignment 1, but just extra stuff. It is, and that's why it's worth the same amount of marks, kind of thing. I try and make it so that you have some good chances to make up. Again, the first assignment, to be honest with you, is the easiest one, and they get progressively worse, right? And I say worse because there's a lot of little piece parts that are to them that I'm asking for. So please pay careful attention to the requirements, right? And if we take a look at this one, again, this is due Sunday, February 12th. So you have a couple weeks to do this one. I'm going to do a check next week, a checkpoint. Right, this is a common thing where I can give you 2% for your user interface in your GitHub, a working GitHub link. All right, if it's not working, you're not going to get 2%. If you just give me a GitHub link that's empty, you're not going to get 2%. If you give me an image that's wrong, you're not going to get 2%. Right, you're going to get 2% bonus if everything is ready to go. And it's my way of pushing you and paying you to start. That's what I'm doing. I'm saying, start. Come on, get going. I want to help you out. Right. So that's what really it's for. It's kind of a checkpoint. In real life, this would be like a weekly meeting that you have with your project team to show them what you have, which I want to encourage you guys to do. We're 50% of your final grade. It's called Sharp Auto Center, and really what it is you create a project that determines the total amount due for the purchase of a vehicle based on accessories and options selected and trade-in value, if any. I'm going to give you a very simple user interface that you can look at and be creative with this one. I mean, if you have time. And I say that because this is the basic interface. If I give you something that looks like this, think about this as a sketch. Some people, what they've done last semester and previous semesters is they've added things like build your own car, right? Just like you do online nowadays. Where if you wanted to buy any kind of car these days, from a Honda to a Mercedes or BMW to a whatever it is nowadays, you could build your car, right? Well, this is kind of a smaller kind of thing like that, where you have a little app that'll help you, give you your final price for the car that you're buying, right? So if you look at what it says here, what's the base price of your car? You set that up. I'm not going to tell you some base prices here. Right now, we're not connected to a database, but you could set up a way that you have certain cars in a selection that you want to do, or just put in any base price. So for me, what I'm going to do is if you don't give me a selection of different cars, because I haven't asked for that here, I'm just going to put a base price in there. And that's what I did for assignment 1. I would put in a value. By the way, you know what I tested your assignment 1 with? $20,000, right, was total sales, and 80 hours. Believe it or not, I got all kinds of variations and just stupidly with that. That was the test. That was the test case. I wanted to see if I got that. And I also tested 0 and minus hours. And I also tested more than 160 hours. I tried to do those tests. All the test cases I told you about for input validation, I did that. There's more opportunity for input validation here, right? I'm gonna try and break your code. That's my job, to try and quality test your code. That's what I'm doing. I might say break your code. I want to try and I'm like the evil guy who's gonna break your code. No. I mean, I want to try and test your code to make sure that it's rock solid, that some other user by accident isn't gonna break your code. So base price, additional options. And this is example of things you can have additional. You can have one or more of these. Now we're exploring the checkbox. The last assignment explored the radio button, where you can only choose one of. So French, English, or Spanish, or whatever you chose, right? Some people put German too, or or Chinese or whatever it was, right? Here what we're talking about is you can choose one, two, or all of them, or none of them, right? That's the other option with checkboxes. It gives you the option of, it's like a Chinese buffet, dim sum, take what you want and leave the rest, right? Same idea here. I use that analogy a lot when it comes to programming, but that's how it is here. Checkboxes are just like that. Choose what you want to eat, and then the rest, don't worry about it, right? You also have some radio buttons areas here. For example, exterior finish. You can have a standard, I called it pearlized, maybe like a white, right? And also some kind of custom detailing you can do for inside and outside the car if you wanted to. This is an old way of doing things, but if you notice, you can have some options that are fixed, so one of these, or maybe one or more of these, or none of these, right? So those are the options. Once you've checked your options, the totals for all that happen right here, right, in your additional options. Then you have a subtotal, right? So base price plus options is equal to subtotal. The options will change depending on when you select it, so that's going to be reflected immediately, right, inside this additional options. That means this box is something probably you won't be able to modify on your own. You can't like sit there and go additional options, $500 extra. Can't do that. The options will make that happen. It's going to be a calculated box. Subtotal, the same thing. Then your sales tax, which is 13%, calculated box. You're calculating your sales tax, right? Then your total, finally. So you get a subtotal and total, and then finally a trade-in allowance, right? Which is optional. You can put in a trade-in allowance figure, and a trade-in allowance means you've come to the dealership with the car, right? It's your car. You own it, and it's worth $5,000 because it's several years old or whatever. Or maybe it's worth $100 because it's a heap of crap that you're driving around with, lots of rust, right? And the police is going to pull you over anytime now, right? Or maybe it's worth a lot of money, but that's a trade-in, right? So then they're going to give you some money for trade-in. That money, whatever they give you for trade, is going to be deducted from the total to give you your final amount, which is the amount due. It's more calculations because I'll tell you, for the most part, when we do utility apps, a lot of the stuff we do is calculations. We want to calculate something. And it's also understanding, in another way again, how to convert totals and how to input or limit input validation from users, or limit input in some way. So streamline that, that kind of process. Notice that you have a calculate button and a clear button like last time, and an exit button, which is going to exit your application. Okay, that's what we have here. So nothing that different than what we had before. Notice that from a submission detail perspective, you need to have a zip archive. Please, no RARs. I've got a couple of them this time around, this assignment number 1. Next time I will just not accept them. I'm telling you right now. I asked you not to put RARs. Some people did already. I use them, but I'm asking you only zip archives, please. And I have a mission. There's a reason for this. Okay, so please only zips. I will not accept RARs coming forward for assignment 2. A link to your project files on GitHub, a working link to your project files on GitHub. If you shared it with me and collaborated with me with one of my accounts on GitHub, great. If you're trying to send it to me via email, no. It's got to be a submission here on Blackboard. Okay, please don't send me your project files via email or via Slack. I've had that too, right? I won't accept them. Yes. Yeah, submissions. We used to use submission text. You can put it in there, right? You can write your submission right there. If you really want to, if you're a stickler, attach a text file, GitHub text, get links, whatever you want to call them, right? You can do that too. Either one is acceptable. I will look at your files if you give it to me. This is heavily based on user interface. So a lot of user interface stuff, controls working, 11 marks. Functionality is only 9, right? This is going to go up. You're going to see how it's going to switch from less user interface and more functionality. That's how all these assignments have been based. So first we start off with user interface. On the exam, midterm, which is happening, we're still at week 4, 3 weeks from now, right? 3 weeks from now is going to be your midterm in this room, exactly on time at 12 o'clock. It'll last for 3 hours. I'm going to gear it for about an hour and a half for that, and around that time frame. So some people will be able to leave an hour and a half. Some people who don't practice and don't do their homework on their own, who work with other people heavily, will work until the last minute to get it done. And some people will not finish, right? So if you've done your work, if you've done assignment number 1 on your own, and you do assignment 2 on your own, midterm will be no problem for you, because we're just going to do more of the same. Nothing new, nothing surprising. I'm just going to get you do some other calculations, some other kind of thing like this, right? That's what you should expect. I'm not going to, kind of pull out of the air that you've never done before, right? And the other thing that might do is get you to do something in class or on the midterm that we talked about in class that I've been marching along with the whole time, right? I'm doing this calculator, we were working on this calculator. I'm getting you to do stuff, and there's reasons why I'm showing you the calculator, because it's talking about things like how to do some logic with C#, right? That's why I'm doing the calculator example. And also using it as a vehicle to add on, so we can keep on adding and adding and adding to give you more functionality, right? 3 marks for program structure, which means you have to have certain things. Like, for example, people miss this. They gave me form 1. Please don't give me form 1. That is an instant loss of marks. Look, if it tells you right here, 1 mark program structure, I want you to call it sharp auto form. I would accept sharp auto, worst case scenario, right? Don't give me form 1. Don't make up your own name. I'm asking you for a certain thing. Give me this, or you're going to lose 1 mark. And in the last assignment, it was exactly the same, right? It's right here under solution structure, right? And I was a little lenient on this. I didn't look for this time around because it's your first assignment, right? But from now on, I want you to structure all private variables with an underscore. Actually, it's on your assignment number 1. Most people did not get it. I didn't want to be that much of a killer, so I felt like a killer DM for a second. Killer DM, you fit demagogue. Remember, just like Stranger Things. I didn't want to do that, so I was going to say, I'm not going to look at every little detail, because some of you would have got way worse marks than you did. Or some of you may have been dragged down, so you wouldn't have got over 100%. Anyways, so please take a look at this program structure, because I've asked you to do something in a certain way. For example, whatever the control name is called, the UI, the control name. So exit, the exit button, calculate button, that kind of stuff would be how I want you to lay it out. Some people did not do that. Some people made their own names, right, or whatever. Did I look heavily at this structure this time around? No, I'm just trying to remind you to please do that this time around, because I will be looking at project structure or solution structure, right? The big one was internal documentation. And I know it doesn't say it here, or didn't say it last time, but please include your student ID. Some people did, some people didn't. This time around, I really like that. That is worth 2 marks, just this part. And then section headers for all your event handlers and classes. That's worth 1 mark, right? Contextual variable names. Some person used KK. Right? Their out variable for their try parse was KK. How does that make any sense, right? You do that. I'm not going to specify who it was, but you do that. That is exactly going against this. This is where you lost that mark, right? Ensure you include inline comments that describe your UI design and functionality. If there's something you need to describe, put it in. If you have to explain something because your variable names are X's and Y's, that doesn't make any sense. Make sure that the code kind of speaks for itself. I hate saying that a code should comment itself. It really doesn't comment itself a lot of times. Now, there is another school of thought around comments, right? The comments are a waste of time, that no one does comments. Even in some professor circles, when we talk amongst ourselves, they're like, I never comment anything, and the code comments itself. Fantastic. But you guys are in a learning situation right now, and I'm asking you to comment your code. Part of it is for me to understand that you understand. Okay, that's why I'm asking you to do it, not because I want to be a stickler when it comes to comments. Okay, so that's the solution structure and comments. From an instructions perspective, it's very similar to what you saw last time, where you have one big instruction area where it says, and I'm very explicit, add text boxes and associated labels. I'm not going to tell you how many, right? To the form for base price and trade-in allowance. Set the trade-in allowance text property to 0. So I've told you to start off with a certain way. And if you notice, as you go down here, it tells you what to do and how to calculate things, how to put things together, right? Especially when you do things like when you calculate, it says add 3 buttons to the form, calculate, clear, and exit. And then what the calculate button is supposed to do, it's supposed to add the price of selected accessories and exterior finish to the base price and display the result in the subtotal text box. It tells you what to do there. Follow what I'm asking you to do, right? Again, in real life, you will not have leeway to stray from the design that that you've been paid to do. You're getting a design from some kind of UI UX person. A designer is going to design your user interface, and then you're going to have to implement. That's what it's going to be like, and you don't have a leeway. You can't sit there and go, oh, I want this to calculate, not this. I don't want it to calculate this way. I want it to calculate some other way. Please don't do that. Right? Follow what I've asked you to do here. Now, where the leeway comes into play is when you feel like adding in additional things, like here's my final form sample, right? But what if you wanted to add some text or images here or whatever? Like you wanted to add car images, that's extra. So whenever you select a car, the image of the car comes up. I would give you bonuses for that, right? You know, other things. Notice there's also a menu. We haven't talked about menus, but we will over the next 2 weeks. We'll talk about how to do menus and how to link menus to controls and buttons. There is a menu on this one. That's something else that's new. But let's say, for example, you wanted to set up a splash screen. So we're going to be talking about, starting today, about multi-form applications. How do I go from one form to the other form? For those of you who are not great with object-oriented programming, today's that day where we're going to start stepping into that different world of object-oriented programming more, because I need to refer to the form as an object. Before, we haven't done that. We just have one form, and now we're stepping away from one form and going to 2 or more forms. You know, for maybe what you're going to have is a beginning form, like some kind of splash screen. You're going to have some kind of input form, and then you're going to have a final form when you get all the details, that kind of application. We're going to make that kind of application today, or maybe even extend our calculator or do other things. And we're going to be talking about how to do that. If you do those things, even though I haven't asked for them here, if you add, for example, a splash screen and some kind of other information in here and add some extra stuff, and you list them for me, so it's nice and easy for me to see what you've added within reason, then fine, I'll give you bonus marks, and we'll talk about how many, right? So for me, what I'm going to do is I'm recording here so you know, if you give me a splash screen, which is a very simple thing, I'll give you 2 bonus marks, right? If you add in some kind of additional images and stuff, I'll give you another couple bonus marks for images, for switching, that whole situation there, right? For your cars or whatever. If you make your code better, right? If you try and minimize your code and use a single event handler for all of your buttons or something like that, you know, as an example, we'll talk about those things, what makes sense and what doesn't. Then there might be another opportunity for marks. And it has to make sense. Like, don't just, you know, work 60 hours in this thing. I'm not expecting that either. It doesn't make any sense. Again, it's only worth 15% of your final grade. It's weighted. It's not going to kill you, though, for you to spend, you know, an inordinate amount of time building this application. From a level of 1 to 10 in terms of difficulty, assignment 1, I'll be honest with you guys, it was probably between a 5 and a 6, all right, overall, right? This one might be between a 6 and a 7, you know. I mean, it's, you know, maybe, and I'm being really, to say that it's a 7 is like, it's not really right. It's really more like a 6, right, in terms of this. As we get into the next one after this, that one's going to be between a 7 and an 8. And by assignment 4, it'll be an 8 or a 9, right? By assignment 5, you're going to go into 8, 9, and 10 territory, right, where it's much more difficulty. The difficulty rises, right? But they're all worth the same marks, right? That means, again, if you did really well with assignment 1, not so well with assignment 2, kind of balances out, right? That's the whole, plus the bonus marks that I'll give you bonus mark opportunities every single time we do an assignment that you could get if there's 5 assignments, 10% bonus, which will eliminate the need for you to have an exam, right? So, you know, it's kind of the structures there for you to, you know, to be in class, to do your bonus marks, to do your labs, to get your assignment work done. And again, when I talk about success with students, if you want to be successful in any class, it's hand in your assignments on time, right? Make sure you make it to your exam, right? Study the night, you know, not the night before, but study what you have to do for your exam. Get all the bonus opportunities you can. Don't throw away your bonus marks if there's an opportunity for those things. Talk to the professor to make sure that you understand. If you don't understand something, communicate with the professor, because whoever it is, me, someone else, so we can tell you what we're looking for if you're confused. If there's something that's confusing you or you're not clear, clarify it. And the one thing that they're going to tell you in project management class when you take it is, hey, ask the sponsor more about the requirements. Drill down the requirements. What do they really mean when they say these things that they want, right? So I'm asking you, I'm inviting you to do that. Come to me and ask me, and I'll clarify for you. If it's a big enough question, I'll put it up on Slack. I'll say, here's general comment. This is what I mean by that, right? If it's really unclear. So again, this is due a couple weeks. We're sitting at week 4. This is due week 6, right? Again, it's by the Sunday at midnight. Notice again, I put some prices. Please don't use these as the only prices. If you really want it to make your own, it's fine. Like if you said, for example, stereo system's not going to be $425, or maybe I have some kind of crazy stereo system you want to list here, and you want to make this list a lot longer, that's fine. The more complex you make it, if you mention that you've made the car more realistic, or you're trying to make it closer like Honda or BMW or whatever kind of car company you will, If you try and mimic something that exists in the real world, again, opportunity for bonus marks. But we have to talk about it. All right. So it's not going to be just like you spending all kinds of time running in a certain direction, then you get 0 for it. I don't want that either. I don't want to waste your time. Right. Look at this as a learning opportunity for you to add additional features. Right. So you can try different things where you have the time. You have 2 weeks. That's what the assignments are there for you to do research and to try and figure out what to do. And in class, when we do tests and quizzes and labs and all that kind of stuff, it's where you get tested and you have no time. Questions around assignment 2. Again, very similar to assignment 1, just a few more details. Okay, and we're going to talk about them. You should know everything about assignment 2 or how to do assignment 2 pretty much today and next week, right? So, and again, next week will be week 5, so you'll have a whole week to kind of figure things out. And again, I just want to repeat this. Next week, you will have a checkpoint. I will check you on your progress of assignment 2. I will not give you the leeway that we had this week, where it was due by midnight. It'll be due by end of class. So if you haven't done your checkpoint by next week, by end of class, that means by 3 p.m. next week, you won't get your 2% bonus. It's for people who have already started their assignment. That's what I'm giving you a 2% bonus for. So please start early and submit often. Yeah. No, 2% final mark bonus. That's what it is. That's worth a lot, all right, if you think about it, right? So please don't, fail to put that together. That is totally worth a while, and I'm paying you to start early. That's what I'm trying to do. I'm trying to get you into the habit. That's why I'm offering the bonus to start early. You start early, you finish on time. Everyone's going to get better marks for it, and it's also going to promote, you getting it in, because the biggest problem students have when they get discouraged is they don't hand something in, and then it starts the whole discouragement chain. Right? Because you didn't hand it in, and now you feel bad, and you have this mark that's hanging because you didn't get it done. You don't feel so good about coming to class anymore, and then you don't do well on your midterm because you didn't hand in assignment 2. Making this up, by the way. Could totally turn a different way. And then now you didn't do well your midterm, and then you decide to drop the class, which is crazy because this class is one of the easiest classes you can do. Right? Honestly, it is. So no other questions around assignment 2? Again, if you have questions, please see me during break. Yes.
Sorry, I just
yeah.
I had one issue in particular. I don't think I was here for this class.
Uh-huh.
How do I actually rename Form 1? I don't know how to do that.
Okay. You weren't here for the class. Yeah. You have to look at the videos. I will show you today. All right. We'll talk. We'll start with Form 1, and I'll rename it right for you. So just watch it. It doesn't take a lot. Right click, rename. That's all it takes. And then you just rename. That's how easy it is, pretty much. And then what it'll do is it'll restructure and refactor your file, so it'll go through all your namespaces and everything else right there, right? It takes literally no effort whatsoever. Any other questions around assignment 1 or 2? All right, let's get right into the meat of things before we take a short break. So assignment 1's done. Again, I will mark the people who submit after this, but assignment 2 is the one that I would be looking forward to seeing. And if you have ideas of what you want to kind of do as extras, talk to me ahead of time so we can talk about things that are viable for you to do. Again, don't try and run down a path where it's going to waste your time. We don't want that. I'm going to start with the PowerPoints this time around a little bit earlier than last time. Last time I kind of hit them, and it was kind of a glancing blow, right, when we talked about this stuff. Today's PowerPoints they're really kind of important, and I got to talk about them because it's around arrays and collections. Arrays and collections are a programming structure, a code structure that is used in C# and Java and C++ and every language that I can possibly think of. It's kind of the meat and bones of how we handle multiple data files or data all together in one. Usually collections, when we talk about collections, we're looking at a list structure, and it's usually related data, right? Arrays also might be a data type, but they don't necessarily have the same structure and cohesion as collections do, right? And they have different methods. They're a little lighter than collections. And what I mean by that is there's certain things you can do with arrays, but you can do most of the things you can do with arrays with collections, but there's certain things you can do with collections that you can't do with arrays. There's methods, almost like extended class methods that you can do with collections, and we'll talk about those things. For example, an array list has different ways of pushing and popping data on or off the stack, if you will. And we'll talk about that. Yeah. Oh, no? All right, so I'm not going to be talking too much about some of the the details. I'm not going to read the PowerPoints. That's for you, right, to kind of go through. But one thing I want to kind of hit, like I said, is the highlights of the syntax, because you should already know about collections and arrays, because that's kind of like, you know, programming 101. I'm making this a little bigger for you. So here's how you declare an array. So type, whatever the data type is, this is the general form. Square brackets means it's array. So for example, an integer array, if that was the one. And then whatever the array name is, right? If it's private, remember we talked about this just now with assignment 2, underscore, please. Use an underscore if it's a private instance variable or member, right, in this case. And here's the other way you can do it. So this is when you declare the array, but when you do this, is this enough? No, it just creates the container in memory. That's all it does, right? So when the array is declared, C# puts aside some memory as a reference. It almost builds a form that's empty. There's no container yet, but it kind of says, okay, I'm preparing to put memory aside. If on compile time, if I see something that's been assigned to the array, I'm going to allocate memory. If not, discard. That's what C# does. It does it a little differently than C++. So there is no memory leak. It does automatic garbage collection in C#, which is similar to what Java does. All right, so again, with one statement, you can do it all. Sometimes this is a good form. For example, in a class scenario, I may want to declare at the top of the class, and then inside of the constructor, I may want to initialize, right? Because that's what constructors are for, right? And typically what we want to do is, this is one way of assigning the container size. I can talk about the array length. Again, this is just arrays 101, array review. And here's some examples. So we have a decimal array. It's called totals. Normally we name the array in plural. So if it's just one object, a variable, it's called total. If it's an array of objects in the same data type, it's called totals. So a pluralized form, right? And here with two statements, you're saying totals. So now that you've declared, you're saying I'm setting aside, I'm going to declare this decimal array. But I don't have an object of this type yet. As soon as I use the new keyword with an array, and I specify the size, and again, this is only one form, now totals is an array object, right? You need to use the new keyword. That means you're making an array object. And an array has certain properties. This array has 4 elements in it. It's limited to 4. We also say that arrays in C# and in Java are immutable. It means you can't change them. Once you've declared them as 4, they can never grow, okay? You can make other arrays. You can copy data from the array to this array, but you can never have an empty array that you can grow dynamically. It doesn't work like that with arrays. Yes?
Sorry, in that example, would that be instantiating to 4 slots each element?
Yes. So, decimals would be 0, right?
Oh, but it instantiates to 0, but not null.
No. If it's a string, it would be null. If it's some kind of object, it would be null, right? Unless you declare the object, right? But typically, if I'm not wrong, it's 0 for 0.0 for a decimal. If it was an integer, it would be 0, right? So it would be whatever the data type is, right? If it's a string, it would be null, or the empty string, depending on what you set it. All right, so initialization for this one, again, this is an empty array of 4 decimal elements. That's what it is, and it cannot grow. And again, this is what it would be like in one line. So the simplest form, okay, for arrays. Here's an array of strings. Again, same idea, 3 strings. We don't have a string length. We just have 3 strings. They could be very long. And notice I can declare a constant here of max count of 100. Now this is, if you look at what I'm doing here, or what this is doing, they're declaring 2, right? So saying decimal prices is equal to new decimal max count. So you're an array of 100 elements, right? And now your discount percentage, notice this comma, there's a comma here, discount percentage, that's another array, another variable, is equal to a new decimal array of max count. So now you have 2 arrays. Can you do this? Yes. Should you do it? I don't know. For clarity, I think sometimes people try and wrestle with putting everything on one line. There's no advantage to this. None from a programming perspective. Commas don't help you. They don't speed up your code or anything like that. I would recommend putting it on 2 different lines with 2 different semicolons. It's the simplest solution and it's clear, right? And again, I'm straying from the big book. Before there you go. There's your defaults. So numeric data types by default value is 0. If it's a char or car, it's the null character. If it's Boolean, it's false. Date time, it's set to the 0010101. And any reference type like classes or structures, they're null. right? That's the default initialization value of array objects. And it's good to know that. All right, and now we're getting some details, some examples about how to use arrays. I'm not going to go over these, but the one thing you need to know is how to initialize. So here, notice that I'm using the M character again because M means decimal, right? And where D would mean, isn't it? F is float, and D is? Is there a D? You don't know? Okay, right? There is. And this is the thing. This is the data format. It's basically what you're saying is the difference between a double. Double is the default, right? If you don't specify anything, it's going to assume it's double. So if you said like 14.95 in this example right here, and we're total 0, the 0th element, this is the 0th element of the totals array, right? Where total 0 is equal to this value. You're assigning a value to this element space, right? This container, which is the 0th element, which is a decimal, because we've allocated decimal memory space for each of the elements, right? If you left the M out, it would assume that it's a float. And does float downsize or downcast a decimal nicely? Yes, it does, because float is single precision and decimal is more than double precision, right? So yes, it would downcast, but it would basically, what would happen is you would lose precision if you did it that way. Code that assigns objects to an array of strings. So again, you can initialize this way as well. And I'm not going to go over that, but it's very similar to other languages you've seen. It's nothing different there. Now, there are ways of initializing things all at once. So at declaration time, what you could do is say, here's a list of values for an array of size 4, right? That's of type decimal, right? This is one way of doing it. And then the second line, here's an array of a decimal type called totals as well. And now in curly braces, I assign 4 values. These 4 values does exactly what this is doing. It basically implicitly types this array of, it gives kind of the, by using the curly braces, it's the object literal notation is what we like to call it, right? And instead of using new decimal, it kind of implicitly puts new decimal in there and assigns values for the first 4 locations of this array. And you cannot make this array any bigger. It's still an array of 4. It just does it implicitly instead of explicitly. Explicitly means I'm telling it exactly what I'm doing. Implicitly means it's trying to infer, it's looking at the right side and going, okay, what is he trying to do here or she's trying to do? Oh, I see. They're trying to make an array of four elements here. Okay, that's what we're going to do. That's what C# will do for you, right? And then this is an example, again, of a string array in the same vein, where you have 3 strings for names, 3 names. So again, we're inferring the type. If you don't mention the type here, if I don't know what it is another way of doing it. So I want to say var. Notice var, the var keyword. And please, if you think var is like the JavaScript var, you're wrong, right? You're going to see var when we do stuff in C#. Var means I'm going to use implicit typing or inferred types. It's very strict though. So whatever I put on the right side, whatever it was on the right side, it's going to make grades that data type. Now in this case, I'm saying it's a new array. And notice I'm passing in a bunch of integers. Well, then that grades must be an integer. And from now on, after this line, you cannot change grades to something else. Not a dynamic type like you might see in JavaScript, right? It's a strict typing, but it's using type inference, to denote what this data type is. And it's the same when it comes to Java. If you use there's also very similar ways of doing things in Java. And in the new Swift language from Apple, right? They use a lot of type inference. And the reason for this, and you might say, well, Tom, isn't this like less structured than the other way? It might seem that way, but it's actually, it makes sense, logical sense. If it's logical and easier and quicker, then it makes sense to put it in. That's why Apple's using it all over the place. In fact, they recommend using it. And again, with Apple stuff, they just say, just take out the semicolons too. Don't use semicolons, with the Swift programming language. So they've kind of diverted their ways outside of, C influenced language. All right, properties for arrays. One of the most common ones is array length, right? You want to know the length of the array. In this case, we have an array length of 4, right? So here you have 4 elements, element 0, 1, 2, 3. So we start, it's a 0-based counting system, just like any other C influenced language. Right? There's some languages. Which language has a 1-based counting system? Does anyone know? Is there a 1-based counting system instead of 0 length? How about VB? Is that 0 length, 0-based, or 1-based? You might be surprised, right? How about Python? Python 0-based, yeah? right? So lots of little languages. Most of them are zero-based. Some are not. And you got to be careful on which one they are. But normally they count from 0 and they go on like any other language you've learned. This is bad form, all right? So for, and I've seen some of this in your assignment 1, where you go for int I is equal to 0, I is less than number length. Sure, you can use I here. Again, what are you counting here? You're counting numbers, right? So almost like you're counting how many. You could call this int count is equal to 0, where count is less than numbers length, count plus plus. And count plus plus is using the incrementer to increment the next to the next number, so we can keep doing this way. As long as this integer value I or count, whatever we would call it, is less than the number's length, it'll keep iterating, right? Now, the reason why I'm saying it's bad form is because there's no curly braces, and I hate when they do this kind of stuff. This is, to me, it's hard to see. People who use C++ do it all the time. They don't put any kind of curly braces in here at all, and that could lead to bugs that you can't foresee, because you might think about, since this is indented, you might put something else indented under here, and then you might think that both are being iterated, and you're like, I don't know why I'm getting this error. I put it inside the for loop. No, you didn't. The only thing that's in the for loop is from here to there. Anything else outside of that, even if it's indented, doesn't mean anything. Curly braces is the only way you can denote a code block here, and I recommend you put it in whether you only have one statement or more than one statement. It's good form. All right. Code that displays the numbers array as an example. So again, this will messagebox.show. Some people have problems with this messagebox.show. Some people put extra stuff in messagebox.show, right? When we did that in the assignment number 1, when I talked about it. So here is a number string. That's the, notice that there is numbers test. Numbers test is the title. It goes here, and number string is what's displayed in the message box. Again, I don't mind message boxes, but they remind me a lot of alerts, right, in JavaScript, which are terrible. It disrupts the user interface and the user experience. We use them as infrequently as possible. Okay. I'm not going to talk about this. This is just more of the same. And I'm going to keep skipping through here until I see something interesting. Oh, the for each loop. This is interesting. So any collection, including arrays, you could use a for each loop. So what you're saying is for every element in, you're using the in keyword, for every element in the array loop, right? And then I can use the element, so example total, and this is a very interesting way of writing it. For every total in totals, add this total, the total that I'm at right now, to the sum. And so instead of using zero-based counting, I don't know how long my list is. I don't have to pass in an array length. I can just keep counting until my array is done, right? And this works great. I use for each loops all the time for array lists or lists of any kind of type, because it's easy. You don't know how big your list is going to be, so you iterate with a for each loop. And this is the right structure after you've initialized an array, right? If you're initializing an array, a for loop is more appropriate because you don't have a length, so you can't do this, right? But for a for each loop, it's good after you've initialized to kind of go through the length, especially when your length is changing, if you have some kind of change. Now, in an array, it's going to be fixed, and you might say, well, arrays are fixed length, so does this help me? Well, if you don't know the array size, it does. And if you're getting the array size from another method, this is a great way of using this thing. But if you know the length, then this is actually less efficient, and the for loop is the most efficient structure. Okay. Oh, one more mention here. I want to ask you a question about for with the for loop. Notice how I'm calculating the total's length, right? I'm going to ask you this question. Is this a calculated value, or is this a property for the array? What do you think it is? And we're going to talk about efficiency for a second. I know people don't talk, ooh, efficiency is a dirty word, all right? But let's just ask this question. So totals.length. Do you think it's a calculated value, or do you think it's a property that's just automatically somehow magically knows the array length? Is there a way of knowing that? It's a calculated value, believe it or not. Is it? Yes. And the thing is, it calculates, especially in JavaScript and in other interpreted languages, it's not recommended that you put it in the for loop, right? We see it all the time, right? And some people will say, depending on the language, like C++, it points to the pointer points to the last location in memory, and therefore you have the length, because you can take that location in memory minus, listen to what I'm saying, take that location in memory and kind of make a calculation to figure out the length. It's a calculation. If a calculation is happening in an iterator like this, it's happening every iteration. If I have an iterator that's running inside some kind of other loop, this can take up a lot of memory. So my recommendation is you take the totals.length outside of this. You don't have to do it here. For example, total var, or I don't know, this will be an integer, int total length, that's the variable name, is equal to totals.length, right? You calculate it once, it's not going to change because arrays don't change, right? And then you put total length in there, and then you never calculate that again through the iterator. Actually, it works faster. And I would ask you to try it out and see the difference with a larger set. A small set like this, you can't tell, right? 5, 10, 100. But when you go to 10,000, 20,000, 30,000, 50,000, then you're going to see there is an efficiency to take that out. Okay, so just notice that. And I'm not going to talk too much about this. We talked about the for each loop, like I said. And as I want to kind of go into the collections elements here. Oh, yes. I also have to talk about creating rectangular arrays and so on. Do you recommend creating multi-dimensional arrays? Just asking. I mean, just in code practice, do you think it's a good idea? Right? Anybody have an opinion? You have an opinion. What do you think? From an array, you're making an array, and I'm making a multi-dimensional array. Why would I do such a thing?
I guess the problem for me is that arrays like that, they're implicitly typed. So
well, they're explicitly typed. They're all explicitly typed. Yeah.
Sorry.
Yeah.
So, if you need something that's 3 columns and 2 rows, go ahead. But I don't see myself using that too often. If I could just have multiple arrays with different names that I could reference data from.
You could do that too. But what about making an array of 3 by 2? That's 3 by 2. That's not big, right? How big is that, right? It's like 6, right? 3 by 2, right? So, I mean, I don't know. There's like 6 elements in there, right? So for this small kind of array, as an example, right? 3 by 2, right? Doesn't make sense. You can make a linear array and then figure out you can develop an algorithm that'll be better than this, right? What we use 3 by 2s or any kind of multi-dimensional or rectangular type of array is from a representational perspective in our mind, because that's how we want to represent it, right? That's the reason why we use it. Yes, you want to say comments? Correct. Yes. You could, but you know what I would rather do instead of doing that? I'd use a class. I'd use a class where I have an object that has make, model, color, everything in the class, and pass an object to a one-dimensional array, right? Makes more sense, and it's way more contextual than passing in, different row column. Unless you're doing some kind of grid, it doesn't make any sense, is what I'm saying. So only use it for something like a grid, especially if you're doing something like, I don't know, you're making a game, and the game itself has a grid. You're dividing the visual space into a grid or something like that, or a table. That's the only reason why I would use something like this. 2-dimensional arrays. And they talk about here how to initialize. Notice that this is initializing the 0, 0 point. Another really good reason of using 3-dimensional arrays or 2-dimensional arrays is to mimic matrices. Okay, if you're someone who does like to do matrix calculations, matrix projections, linear algebra, all that kind of stuff, arrays kind of are really close to that. This is like doing, when I do a 0, 0 array, I can look at the 0, 0th position inside of a matrix, right, in that kind of structure. That makes sense, for doing it that way. From an ease of calculation perspective, it makes sense. The 0, 0 position of some kind of matrix or something else. That makes sense for a, for an array-like structure. But for anything else, you got to really think twice about why you want to do that. All right, here's something different. When we use getLength, that's different than length. The getLength is a method, and it says the dimension index. So here's an example. I'm using numbers and then getLength 0. Okay, and what does this return? Again, the number of rows or columns in a rectangular array. So how many elements do we have in an array, right? And again, getLength 0, getLength 1. Again, if you declare an array of whatever the array size is, you can say for the second row how many, the 0 is the row and 1 is the column. That's how it does it for a 2-dimensional array. And that's a nice little function if you're using 2-dimensional arrays a lot, right? Okay, jagged arrays. This is something different than a 2-dimensional array. Notice that the typing is very similar to what we do with in Java. Java actually declares sometimes this way, right? We have, and so does C++. C++, you have 2 square brackets, and then there's an array of arrays is what we like to think about this as, right? An array of arrays. So I have multiple arrays, I have an array of arrays, and that's called a jagged array in C#. I'm not going to talk too much about this, just another structure for you to perhaps use. Again, an array of arrays is also something we can use matrices to do with. You're doing the same idea as making a multi-dimensional array. It's a form of multi-dimensional array. but what you want to try and do is create, it's a different structure to use and a different initialization. Am I ever going to make you do a jagged array or a multi-dimensional array in this course? Hell no. It's not about that. I want you to know the structure. I want you to have seen it. Again, we're giving it a glancing blow, like Scott likes to say. But am I going to talk about it in detail? No. But it might help you from a structure perspective at some point in the future. All right, so we're going to keep going. I'm not going to talk about upper bounds or lower bounds and a bunch of other things that that it does. I think we should talk about some other things that it can do. Binary search. There's something that makes sense. If I want to search an array for data, as an example, binary search does it. It's a very simple search. Please don't use binary search for a very large array. That doesn't make any sense. You'd probably want to do some kind of other search. And you know what? If you're going to do a search, you probably want to sort the array first. And sorting, what it does is it sorts the elements in a one-dimensional array into ascending order. That's what it does. It actually reorders everything. And that's new because some other languages won't do that. It's because the array, it'll just create another array. It'll return an array. That's what it does. It doesn't create a new one. All right, so this is what this does, the sort function and the binary search. Sorting is really great if you want to put something in ascending or descending order. And we use that a lot when it comes to data management. If I have a bunch of piece of data and I want to sort them in a certain order, sort is a very common and useful function. Okay, we're not going to talk about this and how to search. It just gives you implementation details on how to do that. Again, it's very similar to the stuff we've seen in Java. Array copy. I want to copy from an array to an array, from an index to an index. Again, this is very common because whenever we're swapping arrays, and the common algorithm I like to use is the whole card shuffling idea, right? I could use arrays for card shuffling, right? And the way I would do that is I have a card in one place, and I'm going to switch it with a card in another, in another slot. I'm going to swap them, right, from one to the other. Can I really swap them? When I copy, what do? I overwrite this other one, right? And what happens to the original value? It's gone. So I have to have some kind of other variable that holds the temporary value and then swaps back. And this actually is called, there's a name for this. We'll talk about that later. Okay, I'm not going to go too much more into arrays. Params, keyword. Again, we're not going to use it that often. No is very important. So when I set my array, here's an example of a string array of initials. It's called the initial string. And I have null. Once I do that, right, what I'm using is I'm assigning, it's an empty array. It's an empty operator. Have I assigned any kind of container to this thing? It's a string array, I know that, but I haven't assigned any value, right? And if I test it, right, it may throw a null exception error because if you notice, my initials has never been initialized. It's just null. It's empty, right? The way to fix this, of course, is that you can test for null. That's why we do this. We can say if it's null, then do this. If not, then initialize, right? And that's why we do it this way. But be careful, but this could throw a null reference error. Okay, if statements and arrays and collections are different. We're going to talk about arrays and collections. The most common collection that I use a lot, and more than arrays nowadays. I hardly use arrays nowadays. We have to talk about arrays, but I mostly use lists, right? Why? Because lists are more flexible, right? And notice there's a square bracket, sorry, these angle brackets right here, angle brackets, less than and greater than. We call them angle brackets. This is the type. So whenever you see T, capital T, we almost talk about these as generics, right? This is a generic list type. So if I want to declare a list, notice it says ArrayList in .NET 1.0. It used to be called ArrayList. Now it's just called list, right? And an example of this, it can hold anything. I can put strings in there. I can put ints in there. I can put decimals in there. I could put cards in there. I could put airplanes in there, like an actual class, an object. I can put objects in there. I can put nulls in there. Whatever the type I want, I can put inside it. But I have to declare the type when you're doing your declaration of the list. There's some really interesting syntax we have to talk about. A sorted list, you can use key value pairs. I like to think about this as a map or a dictionary equivalent. That's the equivalent in other languages, right? Very useful structure again, because you can kind of look up things by key value pairs, and you're sorted usually by the key. That's usually the value that you sort by, and the value is the thing that that's contained inside the actual object itself. Each of the elements inside the sorted list. There's also two other ones that are very common in computer science algorithms. queues and stacks. Very, very simple way. But what they do is they're different kinds of list structures in that they're organized in a different way, right? So you can, again, it says use methods to add or remove elements. So what's the difference between a queue and a stack? If you guys know, computer algorithms 101. Anybody know the difference? Yes.
In queue, generally structure follows is first come first out, and stack is first come last out.
First in last out for stack, right?
Yeah.
First in last out. And for a queue, it's first in first out, right? So what kind of structure would be a deck of cards? Is it a stack or a queue?
For deck of cards.
Deck of cards, right? What is it? Think about it. So
It's a stack.
it's a stack, right? It's a stack, right? First in, so the top of the stack, I'm taking from the top of the stack all the time, right? But you can also see it as a queue, no? Depending on how you load the cards up. Well, maybe are you loading it from the bottom? Then it's a queue, right? So it really depends on what you want. You can use the stack or queue analogy however you want. My favorite ones that I always like to look at was like this, right? A queue is like a line, right? So if you're doing a traffic survey, I'm going to use a queue, right? Because I'm there, and then I'm gone, and then it's kind of one line of cars, or I'm lined up at a grocery store, right? And queues actually are much more effective and efficient when it comes to distributing data. So you have, and normally what we see in most grocery chains is multiple lines, right? Where everybody is like going to a different, cashier. But actually, that's wrong. Mathematically, it's not efficient. If we had an unlimited space in the store, I'm saying, right? So imagine if you had a limited length, you could just queue up or line up as long as you want. There's no length, right? Then it makes more sense if I have 6 cashiers that I'm always going to go to the nearest and the fastest cashier. It may not be the cashier in front of me. It could be the cashier over here or here, which means it'll be a faster way of emptying the queue as opposed to multiple cashiers with varying speeds, right? So that's something that we've looked at from a almost like a traffic survey scenario. Stacks, on the other hand, are a great way of displaying or talking about memory, right? We put something on the stack, we take something off the stack, right? So we load the accumulator, we load the stack with memory, and then we remove memory from the stack, okay? So again, different data structures, the common that you might see if you've never heard of them before, they're here, and it tells you on how to use these kind of things. Here's an untyped collection, right? So we code that uses an untyped collection, which is kind of weird. Here's my numbers array list. I say, so we actually say array list in this case, which is a new array list. We don't know what kind of list this is, right? But as soon as we add numbers, right, up to here we're good. These two are good because we're adding the same integer. Once we have one type, it's an array of integers. If I try and do number 3, it's going to error out. It's going to not compile, right? Because now we've added integers and some kind of string value. And you can't mix types inside of an array list or an array, right? But it allows you to do that. If you really don't know the type, you can use an array list structure to do that, which is a little different in C# than it is in Java. But here's the most common way you're going to see it. List, angle brackets, the data type inside equals to a new list. You have to use that structure of type int, right? And then opening and closing parentheses. This whole syntax is required when you're making a brand new list, okay? So even if you declare it first, you might do list int numbers at the top, and then inside your constructor, new list int. You need to do this somehow, both one way and the other way throughout your code. There's other ways of initializing a list, but this is the basic one. Notice that I'm not mentioning how big the list is. And now in this case, if you look at the first line here, under right here where my pointer is, right? Can you please tell me how large is this list?
No, it has a size of 0.
How's the size there? Is there anything inside of it?
I believe just.
There's nothing inside the list. I want you to think about a list like this that's declared as a container, an empty container that has nothing inside of it. And as soon as I use the add keyword, it adds something to the list. Is it index 0? Yes, it does. So I can add, and it'll add a numeric order. So you can use a list like an array, right? And again, this is for people who forgot about lists and who did lists in Java and they don't know the structure. It's very similar in Java. We use lists all the time. It's great to initialize lists with a for loop, like I said, but the better structure to show data in a list is with the for each. And here's some more examples of lists. Now, if you want to, you can specify a capacity in here, but typically we don't do this. This is for limitations. If you want to constrain a list to a certain number of elements, right? You don't know how many, you still want to use the add and remove methods, right? So you can change the size of the list, but there's going to be a limit. So you can't, increase the list. And why would we have that? Memory management a lot of times, because we want to limit how much memory we're using so it's not an unlimited number, right? That's one of the reasons why we do it. And here's some examples of this. There's some really cool properties. Count. Now it says it's a property again, but I want you to think about it as a calculated value, right? Add is the most common things we do. Add, remove, and clear. Clear removes all elements from a list. It's very common. We're going to see this when we do drop-down lists. That's why we're talking about it here. So before we do drop-down lists in C# in rapid application development, it uses the list structure. It actually is a subclass of the list, right? And all these methods that you're going to see here are applicable to the controls we're going to have in our UI, right? So what is it? Does it contain this object? Can we insert into a list? Can we remove from a list? Can we remove at a specific point in the list? Can I do a search in the list? Can I sort the list? That's really common, right? All those really good things are things we want to do with the list. And that's why lists are so much more powerful and very flexible. Okay, and I'm not going to go into too much detail here because it just tells you more and more about stuff that gives you more examples about lists here on the PowerPoint, right? Sorted lists are like the sorted arrays. They have key value pairs again. So again, when you set up a key value pair, you can do things. Sorted lists are, in my mind, a lot more like maps or dictionaries, where you can have key value pairs. And you'll see a lot of sorted lists when we do more with authentication, if we ever get to authentication. And when you do enterprise computing in the summertime, if you guys are in that course this summer, I don't know if you are, or maybe next summer, all the stuff we're learning here, all the methods for lists and everything else, the way we set up forms and everything else with Windows Forms is almost identical with web forms, right? That's how Microsoft has done it. And although it's older technology, like I mentioned, it's still 80% penetration in the marketplace for C# and ASP.NET. So very similar ways of doing things. And it gives you here examples about how to add things to lists. So here in a sorted list, we add key value pairs. This is the example of key value pairs where I have a name and then I have an amount, some kind of value related to the name, right? For example, this would be a great way to store accounts. I got accounts receivable and I have a value for my accounts receivable. I have accounts payable and another one, and then you might have an accounts payable value. You might have a lot of those T accounts. Anyone do accounting at all in this class, right? If you're not accounting, then you know what I'm talking about. You have all these, general ledger accounts as an example, and then you list them all, and they're stored with key value names, which means you can search for them. You can reference that number, so you don't have to use 0, 1, 2, 3, 4. It's more of a friendly name of accessing that particular list item, right? Which is much more efficient than trying to figure out, is it 0 or 1 that's my general ledger for cash, right? I don't know what it is. Most likely 0, right? But that's the way things go. So really good, useful structure. Queues and stacks, they have different commands. On queue, adds, dequeue, removes, clear, and then you can also peek to the next one without deleting, which is really, really valuable. Stacks have a very similar way where you can push and pop from the stack, clear and peek, same ideas, and you can also get a count of how many numbers are on the stack, right? So whenever you use a more complicated structure, like a list, sorted list, stack, or queue, again, we call these generics, right? Because they have a generic type. You can specify the type of the stack, list, queue, or sorted list. And they all have methods because all lists, whether they're one of these lists I mentioned, are objects. They're objects. I've created a new object from the list class. Okay, that's what I want you to think about them. So we use them and we think about them as objects. Okay, and on top of that, we can also derive new classes. So here's a great example of a list class, right? I want to make a list, and I want to make it of type card. Okay, I don't have a card object yet, so I create a class or a structure. So my class for my cards, it has two properties. It has a face and a value. An example would be a face type or a suit, let's say. Suit would be, diamonds, clubs, spades, and hearts. That's the suit type. And then the face value would be 1, 2, 3, 4, 5, whatever, right? All the way to 14, which would be for the king. But the thing is with that, I have these two values, right? So I have two properties, and that's the card that I'm talking about. It's a card object. I initialize a list of type card. That's great. And if you think of what that is, it's a deck of cards, right? Because, and I can call it that. I can say a list of type card deck is equal to new list of type card. That's the way I would do it. And the deck of card example would have a list of objects, right? It wouldn't be a list of integers or a list of decimals or a list of strings. It would be a list of a custom object we created. And that's the power of using lists, especially generics. And that's it really for this one. I'm not going to go too much more detail. They give me more examples, protracted examples about different lists and different things. And the other thing that I want to go through, not right now, we're going to take a short break, is validation techniques. And this is all about validation here, how to handle exceptions and validate data. And this is going to help you with your assignment number 2, because some of you have still some issues with doing this. It's a lot of the stuff we've already covered with try catch. So I'm not going to go over this one. This one's for you, all right, to look at. This is for your reference. I'm going to show you how to do it with code, but I'm not going to go through every single slide like I did with ArrayList, because ArrayLists are really special. We need to know how to do them. But for validation, I would offer you a chance to take a look at this PowerPoint. It comes right from the book, and it gives you all the details you need about how to do validation. We'll do some of them together. All right, let's do one thing. Let's take a short break, 10 minutes now, I think. I think we've earned it with all this talk. And then we come back, we'll get right into building an application. Okay, let's go. So on the break, please, if you have questions about this time, 1, please come to me.